We take the same sample of metals to check out how they react with water. Don't forget a basic aim to find out the order of reactivity of these metals. If a metal reacts more vigorously with water, then it is said to be more reactive than the one that doesn't react as much. Metal reacts with water to form metal oxides and hydrogen gas. And if the metal oxides form soluble in water, it will dissolve the further form to metal hydroxide. So how can we judge the order of reactivity based on the reaction with water? We perform a simple task. First, we take a beaker half filled with cold water and see how the metals will react with it. Some of the metals will react with the cold water, but most of them won't. Out of those metals which didn't react with the cold water, we try to add them to hot water and see how they react. Again, some will react with hot water and some won't. Those such don't react with the hot water, we'll see how they react with steam, and that will kind of see of the order of reactivity. Ones which react easily with the cold water are more reactive, and ones which require steam to react are less reactive. Metals like sodium or potassium react violently with cold water. In cases of these two metals, the reaction is so violent that the evolved hydrogen immediately catches fire. The equation looks like this. This hydrogen catches fire immediately after the reaction. That's how vigorous the reaction is. So we know that sodium and potassium are very reactive. Remember, we're still talking about the reaction with cold water. How does calcium react with cold water? Well, calcium does react with the cold water, but the reaction is not as violent as what we've seen with the sodium and potassium. The heat is not enough for the hydrogen to catch fire. But what happens is that calcium starts floating because bubbles of hydrogen gas form stick to the surface of the metal. And magnesium? Does it react with the cold water? No, it doesn't. But magnesium reacts with the hot water to form magnesium hydroxide and hydrogen gas. And just like calcium, it starts floating due to the floating hydrogen gas to its surface. The remaining metals we see here don't react with the hot or cold water. But aluminium, iron and zinc reacts with the steam to form metal oxides and hydrogen. And the other metals like lead, copper, silver and gold don't react with the water at all.